Okay, so we're talking about optimization. This is really our last topic with derivatives, and then we're going to start after this talking about the anti-derivatives. So this is really the last type of deal with derivatives. So optimization is, well, first off, what does optimization mean in general? That's a good question. I'm sure you've heard this before. Like you want optimal health. What does that mean, optimal health? The best health possible. What about optimal finances? What would that be? The best possible finances. The most amount of money that you can possibly get within a certain situation. Okay, that's all optimization is trying to get either the most out of something or the least out of something. That's what optimization is. Okay, and there's a lot of similarities between optimization and related rates in terms of they're both word problems. That's actually the main thing. So sometimes people will see an optimization problem and be like, oh my god, I'm doing related rates. Or they'll see related rates and go, oh my god, I'm doing optimization. For optimization, you're looking for keywords like greatest or least, or furthest, or closest. I'm sure there's other words out there, but these are the types of words you're looking for. This is how you know it's optimization. So, this is what you need to do, is you need to find function. That's the hard part. You got to find the function, and this is really going back to geometry. Most of these, if they don't give you the function, it has something to do with geometry. Okay? So you need to find the function. You need to take the derivative. And then you need to find the max or min. That's all optimization is. Okay, so let's look at number 1. It says find the point on the line 6x plus y equals 9 that is closest to the point -3, 1. You can draw this if you really wanted to kind of like get an idea. You don't have to. I don't know. Do you want to draw this? We don't have to. No? Yes? No? Okay, so sure. So, what's this equation really equal to? We usually don't do 6x plus y equals 9. We usually set it equal to y. So, what is the y equals equation? So, it's like this graph right here. So, it's got a negative slope and it's up pretty high, like that. And we're looking for the point on the line that is closest to here. So there's a point on this line somewhere which gives us the closest to this dot right here. We need to figure it out. Now if we're trying to think like geometrically, where do you think that point should be about? It should be, use the other P word, perpendicular. Right? So when you draw this line right here, that should be perpendicular. So this is the hard part right here. Right here. This is the hard part. What's the formula we use to find the distance between 2 points? The distance formula. What is the distance formula? I don't know. Over. There's no over. It's really like the Pythagorean theorem. It's the C value of the Pythagorean theorem. You're just finding the distance. Okay? So let's start to plug some things in. So using this formula, let's go ahead and plug in what we really need. So we have the point. We have this right here. So we're going to go d equals the square root of y minus, what's my y point I'm given? 1 plus x minus negative 3, which is plus 3 all squared. This is a setup. Now, are we ready to take this derivative as is? It's easiest if we get down to one variable on the right side there. So is there any way I can get down to one variable on this side right here? Is there like some type of substitution I can make for one of these? Yes. What's my substitution going to be? Y equals negative 6x plus 9. So let's go ahead and do that. So I'm going to get d equals square root of, not y anymore, but negative 6x plus 9 squared plus minus 1 in there. Ah, there he is. He's there. Plus x plus 3 all squared. Okay, so have I done, so that should be a what right here then? A plus 8? Yeah. Okay, can I just make that into an ugly looking 8? Yeah, you can do that. Alright, ugly looking 8. I was making a Neelish joke, but I decided not to. Okay, have I done any calculus yet? I haven't. I'm not going to do calculus till really towards the end. Is there a way I can set this up so the derivative is much easier than that ugly looking thing? Probably. Can we distribute this? So what's 6x? Negative 6x plus 8 times negative 6x plus 8. So what is that? That would be square root of 36x squared minus 72x plus 64. Is that correct? I could be wrong. No, it's not 72. It should be 96. Again, you do have a calculator for this. So this for some of the simple math. Okay, so it's going to be 36x squared minus 96x plus 64. And let's expand this one. What's x plus 3 all squared? X squared plus 6x plus 9. Okay, now one last little step here to make this look nice and pretty. First off, when I take derivatives, do I ever just have square root, or can I rewrite that so it looks nicer? Rewrite it so it has an exponent of 1/2. So I'm going to rewrite it so it has an exponent of a 1/2. It'll be nicer. Okay, let's go in order here. How many x squareds do I have? 37. I have 37 x squareds. How many x's do I have? Negative 90 x's. And how many numbers do I have? 73. Hear a lot of talking. I really hope it's math talking. How do you know? Alright, so let's go ahead and take the derivative of this now. Now we're doing calculus. So I'll do that in red. Here we go. Where's the derivative at? This is going to be chain rule, correct? Oh, good thing we did a review on derivatives. Be chain rule. So it's going to be, what's 37 times 2? 74x minus 90 all over 2 square root of this 37x squared minus 90x plus 73. Skipping through some steps, but you should know how to do this. This is the simplified version. Okay, so now, if we're trying to find a max or a min, I need to find critical points. How do I find critical points? You said set that equal to 0? Okay, Okay, so you're going to set this equal to 0. Now, will this bottom, this bottom, I don't care about it whatsoever. Okay? It's going to give me an undefined point. I don't want undefined points. I want relative maxes or mins, or I want endpoints that are important to me. So I only care about the top. So when we set this equal to 0, I'm just going to get 74x minus 90 equals 0. So what is that? So x equals 90 over 74, which is 45 over 37. Okay. Now I'm looking for maxes and mins. I need to make sure that that is a max. Okay? I'm going to do a step that I never do, and I'm just going to show you, and then I'll never do it again. So I only have one critical point. Do you agree? From all this, my only critical point is this right here. 45 over 37. Okay? Do you agree that the numerator is a line that's increasing? So what's the end behavior of a line that's increasing? So it goes negative, positive, goes down, up. So it goes like... Is that getting a min or a max or what? Gives me a min. Is that what I wanted? Closest. I want a minimum. So we're great. We're good. So x is equal to 45 over 37. Did I answer my question? Oh, now you're finding the y point. Good thing you have a calculator. So you're going to plug that into there and get your y value. You don't set the bottom equal to 0 because you're going to get an undefined point. Which in optimization, these are word problems. We don't care about undefined things. Yes. Anybody going to do this, or am I just going to tell you? Okay. 63 over 37? Anybody going to argue that at all? So the final answer is... Welcome to optimization, folks. So in my little picture here, I'll move it back over in a second. My little picture here, that's this point right here. Again, everything's not to scale, but that's the point right there. That gives me my closest distance. Okay? Any questions? Any clarifying things I need to do? Now, I'm not going to do all these problems because some of them just get like super repetitive. Give me a heads up on that one. So I'm going to kind of skip through some of them. I might actually just do the first 4. I think the first 4 are pretty good. Yeah, hey, it's a good question. What if I ask for the furthest? Well, there is no max, though, so you have to find the endpoints. What are the endpoints of my line? Negative infinity and positive infinity. So we wouldn't ask for that. Unless it said, like, in this range, what's my furthest one? And then, yeah, then you could. You actually need endpoints to do, find that maximum there. All right, hey. Here's a great question. I do this all the time. Because I have a plot of land. So I need the length of a rectangular plot of land, because all land is rectangular, is fenced using heavy-duty fencing selling for $3 a foot. While the remaining widths will use the standard fencing for $2 a foot. I do this all the time when I go to Home Depot. I had to figure out these problems so I know how much I am buying from where. What are the dimensions of the rectangular plot of the greatest area that can be fenced at a cost of $6,000? So I'm going to go ahead and give this picture just a little bit of a drawing. So I have a rectangular plot of land. That's my best rectangle. Deal with it. I'm going to call this X. We cool with that? We're going to call this Y. Okay, what am I trying to maximize or minimize here? Area. What's the formula of geometry? What's the area formula for a rectangle? A equals X times Y. Now, for optimization, I can't have two variables. I need one variable. I need either X or Y, and I can go from there. So I can't take the derivative yet. I need a helper equation. Okay, so I'm hearing some, like, half correct stuff. You're half correct. You only did half the rectangle there. So what's the cost going to be? The cost is going to be... Okay, so how many x's are there? There's 2 of these x's, and how much are each of those x's worth? I mean, it doesn't really matter which one's which, because it will, the final number will just spit out in the end. So, want to make x the $3 one or the $2 one? $3? Okay. Plus, there's 2 of the y's, which are worth $2. What is the cost? 6,000 equals 6x plus 4y. Let's sub out the y, because that's usually the popular thing to do. So let's go ahead and solve for y here. So y is equal to negative 3 halves x plus 1,500. Is that correct math? Someone can correct me. Okay. So what do I do now? Plug it in. So a is equal to x times negative 3 halves x plus 1,500. You can take the derivative right away. But do you want to? You can do product rule. Can we stop talking, please, in the front? Can we avoid product rule? Yes, by doing what? Just multiply the x all the way through. Alright, ready for the derivative now? Let's do it. What's the derivative? Negative 3x plus 1,500. How do we find the max and min? Set it equal to 0 and find the critical points. So in this case, what's x going to equal? So I'm going to get 1,500 equals 3x, so x is equal to 500. Did I answer my question? No. First off, we can check if this is a max or a min. How can we check this? So the original right here, that's a line that's going down, the negative line. So it's going to go up down. So is this a max? Yes. So it's good. That's what I want. So it's going to be 500. I want the dimension. So I have one dimension. So x equals 500. How do I find the y value? Plug it in. Want me just to tell you what it's going to be? Alright, if you plug it in, you're going to get, which is right here, by the way, y equals negative 3 halves times 500 plus 1,500, which equals 7,500. So the final answer is 500 feet by 750 feet. I'll zoom in so you can see that a little better. Did you just say this is the warm-up? No. Next one's pretty straightforward because you don't need to find out an equation. It gives it to you. We good here? Ready to move on to the next one? Okay, so sometimes these optimization problems are like super nice and they give us the formula. Okay, so you have a chemical manufacturer that sells sulfuric acid in bulk at priced at $100 per unit. If the total daily production cost is X units, is that the cost function, and the daily production capacity is 7,000 units. How many units of sulfuric acid can be manufactured and sold daily to maximize profit? And then would it benefit the manufacturer to expand the daily production capacity? So let's just think about, what are we trying to find the max or min of, by the way? Where do you see that verb that tells us if it's going to be a max or a min? And then what are we maxing or minning? Profit. How do you find profit? Economics. We thinking economics yet? Revenue minus cost. I'm agreeing with you. I'm not saying you're wrong. It's revenue.
Well, but you just didn't go, yes.
Yes. Great answer. What's our revenue? We don't have that. We need to figure that out real quick. It's the first sentence. You're selling it for $100 per unit, so your revenue is going to be 100x. Minus, what's your cost? Gives us it. So let's simplify our p here, and then we take the derivative. We're going to get negative 0.0025x squared. I'm just putting it in order from highest to not highest. Plus 50x. Minus 100,000. Am I ready for a derivative? Yes, that's correct. We are ready for a derivative. Great answer.
Was it minus 50x also?
I had this 100x right here, so 100 minus 50 is... Here we go, let's do my derivative. So I'm going to get negative 0.005x plus 50. If you notice, after like my figuring out my equation, all of these steps are all the same. I said this. The first step is usually the hardest, figuring out what the heck you're trying to do. After it, it's typically simplistic calculus with power rule. First one, that was a little bit of chain rule, but usually it's power rule. So what do we do now? A very good class. Set that equal to 0. Because we're going to find the max or min, find the critical points. And sometimes there's multiple critical points. You need to figure out which one is a max and which one is a min. We've been kind of lucky where everything has just been, our derivative has just been a line every time. So we set this equal to 0. I'm just going to tell you that x is equal to 10,000. And is this a max? Because we want a max. Well, my function, that's a line that's decreasing. So it goes up, down for the end behavior. So this is indeed a max. Alright, so how many must be sold to make a profit? It's 10,000, right? But there's a snag. Look at the third line, or the end of the second, beginning of the third line. Capacity is at 7,000 units. That's how much they can make. They can make... Okay, so this one does have endpoints. On the previous problems, we didn't have endpoints. Because this is absolute extrema. So what are my endpoints here? 0 and 7,000. You can already tell which one's going to be the higher value. 7,000, because it's increasing the entire time. Okay? So if I do my little chart right here, alright, I have 0 and 7,000, just like I would for when I do any type of absolute extrema. I plug in a 0, I'm going to get a negative $100,000. That's not good. That's pretty bad. I'm plugging it back in here for profit. If I plug in a 7,000, can we pretend that I'm going to plug it in? I actually have the answer in front of me. Cheater? Yes. Whatever. Yes, calculator. I have a calculator in front of me. I did everything beforehand. Not true at all. So to answer the question here, so what's the maximum? 7,000 units. What's the next question say? When you plug this back in? Trust me, you plug this back into the formula, you get the number you get. Okay, so what it benefits them to expand the daily production capacity? Yes, what should they expand it to? 10,000. Why would they expand it to 10,000? Make it their max. Two more types of problems. So we've done distance, we've done 2D geometry. That was a rectangle. We've done profit. There's really two more types of problems that typically appear, and it's going to be volume, and it's going to be, again, 2D stuff, but inside of a function. So we'll do a volume one right here. So we have a cylindrical can that is open at the top. That's important to know. And it holds 500 centimeters cubed of liquid. Find the height and the radius that minimizes the amount of material needed to manufacture the can. So let's talk about... Anybody here, I'm trying to look at your water bottles. Okay. Anybody here ever drink like a can of soda? You know what a can of soda is? Okay. They were produced at a certain shape on purpose. A water can. A water can. Whatever. Whatever goes in the can. A tea can, a Monster energy drink can, a Red Bull can. They were produced at a certain size so that they could maximize the amount that can go in it while minimizing the material needed to create it. Now with them, they have other variables because they actually don't have, their shape of their cans actually isn't a maximum, but they have to include other variables such as like, they have to include all the drug information, it has to be at a certain size, they want to include how big they want their label to be, so that's all in there in those variables. But in general, what they want to do is they want to maximize how much goes in that can while minimizing the surface area. That way they can have as much as they need with limiting the cost. Okay, so this is nice. It kind of gives us some information here. So we have a can that's open at the top. So I'm trying to minimize what though? The amount, which would be the surface area. So here's my surface area of a cylinder. Okay, but the cylinder they're giving us isn't just any old cylinder. It's got an open top. So let's talk about this. for my surface of a cylinder. What does that 2 pi RH represent? 2 pi RH. It represents the rectangle if you unroll a can. Yes, if you unroll a can, it gives you a rectangle. And what else happens when you dismantle this can? You unroll and you get a rectangle and you're left with what? 2 circles. So this represents the 2 circles. But in our special can here, do we have 2 circles? We have how many circles? So our surface area is going to be 2 pi RH plus pi r squared. Okay, I cannot take this derivative yet because I have too many variables. Is there a helper equation that can assist me? Maybe it has to do with like the first sentence. What's the volume? So this is the formula for volume, but it tells me what exactly about the volume. It's 500. Okay, so look at my surface area formula. Which one do I want to get rid of? Do I want to get rid of the H's or the R's? Which one's easier to get rid of? The H. There's only one H I have to deal with. I don't have to square anything. So let's go ahead and get H by itself. So when I solve for H, what does H equal? So let's go ahead and rewrite this now. So surface area is going to equal 2 pi r times 500 over pi r squared plus pi r squared. Can I simplify that surface area formula at all? So let's just take the derivative. The answer is yes. Okay. So these pi's cancel out. You agree? And this r in the bottom is going to turn into r to the negative 1. So I'm going to get 1,000 r to the negative 1. Plus pi r squared. Now that derivative is set up pretty nicely for us. Let's go ahead and take the derivative of the surface area and then set it equal to 0. So we're going to get negative 1,000 over r squared plus 2 pi r. And we need to set this equal to 0. Very good. Alright, so we set these equal to each other. So actually you get 2 pi r equals 1,000 over r squared. So when I get r by itself, it should get r cubed equals 500 over pi. Do I need to go through that math at all? So how do I get r by itself now? Cube root it. So far I'm just showing you everything without the calculator, because I don't need it at the moment. It's totally possible for you to do these problems without a calculator. They could be on a non-calc problem or portion. Okay, is this a maximum? Just say yes. Because there's nothing else we have. It has to be a maximum. We can go through this right here and prove it, but I don't have time for that. Just write it down. Trust me, it just tells the grader that you know that it's a maximum. You don't need to show the work involved into it. It's the only point you have. It has to be a maximum. If you had 2 points, then I would argue you need to do more work. But you only have 1 point, so you're good. It wanted to find what? The height and radius. So I have the radius. How do I find the height? I plug it into here. So the height is equal to 500 over pi times what? 500 over pi to the 2/3. I'm going to do a little bit of a math spoiler alert. Ready for this? Alright. I don't want to... It's a good time. Did you know this is the same exact thing as the cubed root as 500 over pi? So the height and the radius are the same thing. That happens because of algebra. It multiplies the top and bottom by 500 over pi to the 1/3. Yeah, well, you need to be sharp at algebra to do calculus. Alright, so my radius is equal to my height, which is cubed root of 500 over pi. If this was a non-calc question, answer. If it gives you a calculator in your hand, I'll just tell you what that is, which is 5.419. Do I have any type of label here? Centimeters? Is that good enough? Okay. Can we move on that? So I'll show you one more problem. Because y'all don't want to hear me talk for 38 minutes, but too bad. Then we go another 5. So typically optimization is taught into 2 days. That's non-block scheduling. So we're on block scheduling. So that's why it's just going to kind of cram it into 1. What's that? Yeah, I mean, well, usually I would teach it in 2 45-minute days. But we're block scheduling, so it's going to go down into 1 90-minute day. Alright, so we have a rectangle that's bounded by the x-axis in the parabola 4 minus, or y equals 4 minus x squared. What length and width should the rectangle have so that the area is a maximum? So essentially, you want to draw a triangle, or not triangle, they could do triangle, but we'll do a rectangle where the area is the largest inside that parabola. Believe it or not, this is one of the easier problems. Because what are you trying to maximize? Area of what? What's the area of a rectangle? In this case would be, let's be careful, look at this exact rectangle. This is x right here and that's y, so that's an x there, and a y there. So how many x's are there? So it's 2xy. That's the hard part. So do I have a helper equation to get rid of that y or that x? Yes, it's actually right up here. It said this is one of the easier problems. It's not a lot of work to do to set everything up. Problem gave us everything that we could ask for. I'm kind of going fast because I want you to be doing some of these problems on your own. From here, it's just algebra. Are we ready to take the derivative now? So what we're going to get? Eight minus 6x squared. Solve for x. You're going to get square root of 4/3. Why is this not plus or minus? Because it's area. Can I have a negative for area? Nope. Make my little sign chart here of square root of 4/3. It wants maximum. That's what it's going to be. Again, you can always plug in a point that's less than square root of 4/3. Like a 1. And figure out that, okay, it is positive. And you plug a number that's bigger than square root of 4/3. If you're not confident, just pick like 100. Which would be plug it in there, get a negative value. Did I answer my question, though? I have the x value. I also need the y value. So y equals 4 minus square root of 4/3 squared. Which gives me to 8/3. 8/3? Final answer 8/3. I know, yeah, it's 4 minus 4/3. 8/3. So the final answer is going to be square root of 4/3 by 8/3. That's those are my dimensions.